So I think we were working on writer. And if I remember correctly, we were just playing with implementations of this Expr thing. Here, put this over here. You're pretty far away though. I think I need to move this monitor down quite a bit actually. And if I move this monitor down a little bit more, it'll be fine. I didn't want it to be too low. I kind of wanted my eyes to be in the center of this monitor, but this top one could probably come down at least in a 2 inches. Be a little easier, but I'm not gonna do it now. Sorry. Hello, viewer. Hope all is well. Tell me your day was fantastic. At least I hope it was. So it says, yeah, so we wrote this last. That's what we wrote. So the next one is basically there's some other primitive operations available to writer monads. You have the tell operation, which is what we were playing with here. But there's also something called the listen. I think we looked at these last time. There's also pass and censor. So it's just kind of, you just need to know what all of these things are. So the next one we're going to play with is actually called RWS. And RWS is, I'm not going to implement all of, actually, let's not even do it here. Let's just discuss it probably. So that's going to be down here. Okay, so RWS is a monad transformer. We're not talking about the transformer part. We're just talking about the normal RWS monad. Or it's not a monad. I mean, it is a monad, but it's not just a monad. I'm trying to avoid using that. But yeah, you just feed identity to RWST and you get RWS. So if you give it a initial configuration and a state, it will return back an A, an S. So you're basically getting a state back with an additional writer. So that's kind of the additional tag. So that's how a writer works. So this piece right here is the reader piece. This whole thing here is the state piece, and that's the writer piece. And then it appears that you can generate all kinds of output depending on what you're trying to do. So that's cool. And then I think there's like a bunch of subcommands in here. So, right, you have all the reader operations that you would expect. You have all of the writer operations that you would expect. So we were playing with this tell and listen before. Let me see what's going on my phone. It says that I'm live. Just quiet that down. And then it also has all the state operations that you'd expect. So it's kind of just all of these at once. And if that was something that you really needed, then you could get it. So that's kind of useful, I suppose. It looks pretty wild to work with, but if you needed to do all three of these things, you could do it in a primitive type, but or I guess this is a algebraic data type. Or no, this one's just an abstract data type, I think. I still don't understand the difference between the two. I should probably pay more attention to that kind of stuff. So anyway, that's pretty neat. So the next thing that we're going to talk about is, we're done with that, basically. That was a very short section just to explain that you can do it. We're going to talk about bi, contra, and profunctors. So the functor type class, it's really dark in here. I don't know why. Does it look dark in here? Oh, also. Okay. the functor type class provides the ability to modify the value contained in a monad, the types of fmapped used in the context of each of these monads. So we understand how to do fmap for state, reader, and writer. It's basically essentially the same. We implemented all of them, so but we've done that probably multiple times now. So it says, take for example, can modify the aggregated value. Okay, so let me just open up like a little playground, I guess. What's in here? Okay, this will work. So section 6.5. That's not tearing, is it? I don't think it was, but now I'm concerned. Oop. It's weird to have that thing pop up in front of you all the time. Oh, I did have that right the first time. Not in scope. What? No. I mean, writer. Confused. Isn't that defined in here? Oh, maybe I need to specifically ask for writer lazy? Oops. What? Why would these work? Or, well, this one. These ones are type constructors, but this is a data constructor. Why would that work and not that one? I mean, if that doesn't work. Yeah. You have to be joking with me, right? Like, it's clearly joking. Is this not exported? Or am I not getting the type? What? I don't understand. Shouldn't this complain? Am I missing something really obvious? I probably am. You can't come up here now. We gotta... I don't know how I'm gonna keep you from coming up here, though. We might have more Andre sightings now. But I don't think he can actually walk past there. No, he can't. So he's gonna walk in front of the screen. But, you know, you probably won't even see him, actually. You might see his tail. We'll see what he does. Is this like one of those things where we have to do something special that I just don't understand? I mean, if you just do this, can you just redefine the type? But then you still have to, like, you just write writer equals writer t w identity. You're gonna get a... Yeah, see, that causes an error there. Why? Why is only this one causing an issue? Okay. Dear Google. Haskell import writer giving not in scope. Sorry, wrong way. Data constructor. Oops. What if we do it qualified? I mean, this is not... Maybe if we do it this way? I don't know what this... I forget what this exactly does, but maybe that's important? I mean, I legitimately am confused at what's going on. So it does give you a data constructor not in scope, but isn't this a data constructor? This is just a type alias. Am I stupid? Stupid. That's just a type alias. Okay, so we have a type. This is just a type alias. How do I... How do you get the data constructor? Hey Lumi, what's going on? I'm apparently really stupid, so maybe you can answer this in like 0.2 seconds. Also, I just noticed your little first there. Founder. Thank you for being a founding member of the chiroptical stream. So I'm apparently losing my mind. This monad trans writer exports a type constructor writer, but no data constructor. Right? Am I reading, or like, I'm thinking about this correctly? Yes. Do I need to wrap this into like a new type so that, I guess I do. Or am I supposed to write just feeling really dumb right now. Writer. Sure. Function called writer is made available in lieu of a writer constructor. Well, so I encountered this code in the book. I think it was like this. I encountered this code in the book, right? And so I was thinking, you know, I was expecting this to work, but it really only works if you define your a custom writer type, because there is no data constructor for writer. So do I need to like, okay, let's ignore transformers here. I think that's the thing we're having trouble with. Writer. If we just use our writer type, this will work. There we go. Okay, so yeah, so this is expecting you to use, I think this is expecting you to use the custom writer type, because there's no data constructor in transformers. So do people just write, you would use something like listen, and you know, you're using the functions that they give you to do this stuff, but how do you extract? The idea is the library encapsulates over the implementation and only exports an interface, not the constructor. Yes. Okay. Okay. So so this code only works because we have a custom writer data constructor. If you don't have a custom writer data constructor, then this doesn't work. We could have written a new type that just gave us a writer data constructor instead of just the type, but then we have to like hide it when we import the library. So anyway, yeah, it would just be like a simple new type. Yep. Okay. And we could replace, like, if you wanted to use transformers directly, you could replace this with a lowercase writer, because that will just it acts like pure. Yeah, it acts like pure, but there's no uppercase data constructor called writer, so you would have to put either pure here or writer itself, like lowercase though, the function. Okay. Anyway. Yeah, that makes kind of sense, but so anyway, the point of this is that it says given fmap and map writer, writer can be thought of as a functor in both type arguments. Bifunctor is an extension of functor composed of those types that support mapping in both positions. So I think we've talked about bifunctor before, but I'll just write it in here. I think there's a package called bifunctor, or it's standard. We'll find out here in a second. So there's a first function. Oh, I don't know if I mentioned this, but I think it was Lumi that was pointing out that like there was something wrong with my config for Vim. I'm pretty sure it was you, and I've since fixed that, so it behaves a lot nicer now. It's less aggressive on the autocomplete, and like I only have to hit enter twice. It's in base. Okay. Maybe I mentioned that to you last time. Well, it doesn't seem to complain. So anyway, you can bimap and use these first and second functions. Yeah. Okay. I need to actually make this font a little bit bigger. So like all of you are really far away now. Like you're really far away. You used to be like right here, just within hand's reach probably. And so I can't read the font up there. It's too small. I do kind of like you up there though. All right. The situation with reader is similar, except for one small detail. Let us look closely at the signature of with reader. Oh, we'll just write with reader, which is RS reader SA reader RA. Undefined. The key part is the map over reader is inverted with respect to the given function. You give with reader a function that takes an R and produces an S, and then you can transform a reader with environment S into a reader with environment R. In this situation, we say that reader acts as a contravariant functor in its first type argument. The converse situation of normal functors is referred to as covariance. Yeah, so we know that. So yeah, so because of the way writer is constructed, it's a covariant functor that's also a bifunctor. Wait, no. What's the right term here? It's just bifunctor, yeah? Can it be both? You know, I had this terminology nailed down and I totally forgot it. What's up, Jappy? So it's yes is it's both? How was the rest of your stream? I had to step out a little early. I had students. It looked like you were having kind of a rough day of it. Mm-hmm. Hmm. That sucks. I'm sorry to hear that. Were you streaming the whole time? How long did you end up streaming? That's pretty long. Wow. Oh, I guess 6 hours isn't that long. I thought it was a lot longer. I mean, it's a long time to stream and to talk out loud. That's exhausting. That's why I only do 3. Okay. Another example of a contravariant functor is a predicate, that is, a function that returns a Boolean value. Right, so the A is on the left, so it's negative. So if you have the identity function with a negative and a positive, that's a profunctor, right? If it's on both sides. If it's only on the right side, then it's a covariant functor. And if it's only on the left side, like a predicate, then it's a contravariant functor. Oh, missed one. Both sides is invariant. Okay, right. So how does the profunctor work again? I can bring that up. You don't have to explain. I mean, you might want to. I know you like the category theory. Profunctory. I love profunctors. They're so easy. Reddit posts could be dangerous, I suppose, but dimap. All right, so I had covariant and contravariant correct. Yes? I'm pretty sure I did. I didn't read carefully enough. One way to generalize functor is to be a functor on 2 type arguments. Yep. So basically can you guys read this? If this is too small, just let me know. I can plus this. Bifunctor you can map on both sides of either a tuple, whatever. There's another sort of way to generalize a functor though, flipping around the function that you pass around to fmap, which gives you a contravariant functor. Yep. A profunctor is what you get when you smash those 2 generalizations together. It's a bifunctor that's contravariant on the first type. Basically, it's some type that you can map over both input and output. The simplest type that maps to this is arrow. There's a number of other profunctors though. Okay, it's some type that you can map over both input and output. For example, you can define a profunctor for Kleisli or for left fold. How do you map over the input? Okay, thank you. I'm going to go with Mateus. Am I pronouncing that right? Also, hello. I don't think I've seen you on the stream before, so Do you write Haskell regularly, or just kind of interested in checking it out? Kind of. Okay. If you can like write it in boring English words that I can pronounce, I might be able to get it correct. I like trying at least. Invariant is something else. Just a prof. So how do you map over the input? That's the part I'm a little confused about. So I gotta look at DIMAP, right? Like that's key, probably. DIMAP. Oh boy. Okay. We take an A to B, a C to D, and we make a profunctor of B. I wrote some code in Haskell, a HTTP API with Scotty, and a parser parsec. Yeah, that's a good amount of code. Those are both really hard things to do. So if you can write those, you're doing fine. B to A and C to D. Okay, so it's contravariant in its first argument and covariant in its second argument. So you're basically smashing together contramap and fmap, right? That's the idea? That's interesting. I'm probably saying it wrong. I'm always saying it wrong, but oh, apparently I didn't. What is this YouTube video? A YouTube video? Oh, hang on. I'll listen to it. I like pronouncing things correctly. You probably won't be able to hear it because I've muted the audio, but it will be enough for me. I'll listen to it real quick. I'm just listening to the pronunciation of his name so I can say it correctly. This is a silly website. Mateos. Is that close? Mateos? Yep, great. Okay. I will try to say it correctly. I will do my best. If you visualize it, it's like wrapping it up. I don't know what that means, but I suppose it will make more sense when we start doing category theory. Wrapping it up. Mateos. Okay. Practice. All right. Oh, they literally DIMAP is on the next page. So I'm going to consider the following type of functions that return a given type R. All right, we're going to do an exercise, by the way. Finally, love exercises. That's why we're here. And then we're going to submit a pull request, and then we're going to start chapter 7, which I don't even remember what it is offhand. Hopefully it's interesting. So consider the following type. New type. Oops. Return RA equals, I'm going to write return here instead of R, AR. Okay. This returns, that's a weird, okay. This return type is an example of a contravariant functor. Write the corresponding instance. Hint, the code is similar to that of the predicate. Yeah, to be fair, I don't have much experience verbalizing visualizations, so I may just be saying meaningless words here. That's fine. I think that's a really hard thing to do, generally speaking. Like, that didn't click with me, right? That doesn't mean it wouldn't click with somebody else. Like, if you said that to somebody else, they might be like, "Oh, wrapping it up. Of course, that makes perfect sense." But I don't have, like, it didn't get there for me. So we're gonna write I don't, this comes from, oh, it's really contravariant. I mean, we could just import the library, right? I'm pretty sure it's just called contravariant. We can go look real quick. Oh, this is in base. I didn't realize that. I thought it was part of another function or another library that Kumet wrote. I still don't know if I'm saying that correctly. I don't think we've decided how to pronounce his name properly. So I should just be able to import data functor contra variant, and we should be good to go. And then we can write instance contra variant return R. So we're going to take an F, which, reminding ourselves, is going to take an A. Wait, what is it going to take? It's new. Okay, so it must have been part of its own, yeah, it must have been part of its own library until it got included in the standard. Right, it takes an FB, that's the trick. Okay. I keep going the wrong way. I think that when we did, I don't remember exactly what book we were doing. I think it was just in Haskell programming from first principles. We imported contravariant at one point. So I do believe that it was an EdMat library at some point. We might still be able to find it, actually, if we look hard enough. This is just as a reminder for me, because I don't remember exactly how this worked before. So we're gonna have return of raw. So we have here, let me, you can only do one thing. I can only do one thing. Oh, with the function, I got you. Implement contravariant. I'm guessing so A to R. So this is we have a B to R. A B to R. We need an A to B. B to R. Am I stupid? Probably. I don't know why every time like I come back to these types of problems, it takes me like a really long time to just like adjust and go, oh yeah, these fit together perfectly. But for whatever reason, I never am able to do that when I first come in here. Right, so if that's a B to R. To B. exactly what I have. If I have need to compose F and RA this way. Nope, it's the other way. I was hoping I'd get it right the first time, but I didn't. All right, so what is... Yeah, I'm still feeling really dumb all the time. It's really problematic. Right. We have to create a B so that we can create the R. It's the right to left problem. It's the right to left problem. Like, I always want left to right, but that's not how compose works. I don't know that it's a problem. I mean, it's a feature, but yeah. Okay, anyway. I get to look like an idiot on stream. It's classic. Okay, cool. So that's that. So it says the nomenclature introduced in this chapter, bifunctors, contravariant functors, profunctors, is becoming increasingly popular for speaking about types with interesting relations with respect to changes of type parameters. Speaking about functors and monads, we tend to focus too much on what happens to the last type argument because that is the one the one those structures play with, but we should not forget that such focus is a side effect of the power of the language we use to describe those structures. If we look from a more abstract perspective, functoriality appears in many more places. Okay, cool. Yeah, I constantly feel like a moron. That's what I've learned when I live stream, and like sometimes simple things are just not simple. I mean, I guess this is not that simple, but really not that hard either. So what do we need to add here? I think it was also Lumi who showed me the git commit -v. It's fantastic. I really like it because I mean, we wrote a lot of stuff here, so not going to. You don't know what to call it. It may have been Simon then. It may have been Simon. S Shine. So I'm not gonna. Oh wait. We need a few things. First, I need to plug this in. And I also need to get those pull requests. This counts. Doop doop doop. Just do. All right, and technically that finishes off our Hacktoberfest as well. Does that like show anything cool if you just finish it? I want to look real quick. I'll do it off. I'm just doing it off the screen just in case. Oh, it might be too. Oh, there we go. Okay. It just says that they're going to go through some sort of review period, and apparently in 6 days I'll find out if I've completed the challenge. I actually still have I have other pull requests that I want to complete, so even if these aren't accepted or whatever, I'm gonna keep doing some. So I still have, just for reference, I have the diamond text stuff, which I think we've made a decision on, but I still am waiting on that. And then I'm gonna do a bunch of these, so there's at least a few there. So that'll be a few more. And then there's other of these tech support too, so I'll probably do those too. I mean, I don't know how many of them are gonna happen in uh October, but we'll see. Good. So I guess I can just get pull, right? I don't need to merge anything. Delete. No. Branch D. Got it. Okay. Let's get, oh, no. Stack new chapter 7. Okay. Lumi says, I personally like to think that the notation of Haskell actually kind of gets in the way of actually learning these concepts properly sometimes. There are other visualizations and more terse notation. And yes, notation, I agree with that completely. Notation matters for learnability. Depending on whether you are more of a visual thinker or verbal thinker, there are different ways to actually internalize concepts such as these and get good intuition. I think for me, right now, like I just need that repetition, right? Like we take a lot of breaks in between doing writer and reader and these sorts of things, and so I don't have any repetition with the concepts, and then like I come to it and it's almost like I'm looking at it for the first time again. And like I knew the answer for that was either them composed one way or the other, right? It wasn't like I didn't know that it was going to be one of those, and I knew I needed to compose, but like I was trying to just get it without, get it right the first time, and I didn't. So it is what it is. That is not a command. Also, I think a big aspect of category theoretical concepts is that for them to drive good intuition, you need to know many real use cases of them. Yeah, we're gonna find that out soon. I have, by the way, we're gonna start the category theory stuff next Monday. So just keep in mind that if you want to participate, I have the GitHub link there for you to check out. Jappy says he spent a week straight building a predicate library to learn contravariants. There you go. That's the thing, is like just it's repetition. Mm-hmm. Yeah, the concrete stuff is also something that we lack. So, yeah. Anyway, okay, so this one is a chapter on failure and logic. So let me fix up this here and logic. Oops. Okay, there we go. So, yeah. Says lists and optionals were some of our original examples when we introduced the concept of a monad, but in the moment, we only scratch the surface of what they actually give us. In this chapter, we deepen our knowledge of those types, in particular with respect to computations that may fail. I assume that means we're going to learn about monad fail. We will see that the ideas of multiple return types from lists and possibly absent values from optionals can be that reads so strange on stream. If you don't see the commas and I don't like take a proper pause, it's pretty hard to connect those. So I'll just read the outside sentence. We will see that the ideas of multiple return types can be united under a single umbrella, monad plus. Oh, okay, not monad here apparently. Anyway, I tried. Up to now, we have been using maybe in a sequential manner. That is, we execute a bunch of statements one after the other, and if any of them fail, we stop at that point and state that we have nothing to do in return, or nothing to return, by means of nothing. Sometimes we have a plan B, another computation that we want to try if plan A fails. I don't really want to do this all too much. I like to do stuff. All right, so basically we have alternative. That's it's monad plus. So we'll get there in a second. So there's this alternative function. Oops. We'll get to monad plus here in a little bit, I'm sure. Yeah, so this function is actually not, if I remember correctly, it's actually not the proper implementation of alternative as we see it in the standard library, because in if you combine multiple justs, it actually this one is not assuming that X is a monoid. That's the difference, right? If technically semigroup, but whatever. If X is semigroup, then this looks a little different, right? I'll just write it. So just because I want to think about this out loud. So semigroup A right? So it would look like that. I'm not going to implement the whole thing because it's trivial to implement. But anyway, so this one doesn't assume that you have that semigroup. So you basically just throw away the second argument. I actually needed this at one point. I think Lumi, when we were talking about the basically FizzBuzz. Although I think we sort of came up with the best solution of that, so let's ignore that. I don't want to talk about FizzBuzz anymore. Okay, so it says now we can describe the more complex validation procedure. Apparently can't speak today either. So this isn't going to compile, but it's just trying to show the idea. Oh, you know what? I just realized something. Hang on. Chapter 7. I didn't update my title. Oops. Validate name, Dutch or whatever. There we go. Okay, so well, the one we talked about there wasn't really the best solution. The other one I showed earlier on stream with the test function actually avoids a branch, which makes this, strictly speaking, an interesting implementation, unlike the maybe mccat based one. Wait, what stream? Earlier on stream? Oh, like the one of the last times we had the stream. That's what you mean. Yeah, okay. It might be nicer, but it's a little harder to read. The one with mccat, well, yeah, the one with mccat, I think. Excuse me. Let me say this again. The one that you had with the list comprehension, I thought was the easiest one to read. Yeah, I remember what you mean now. It wasn't obvious to me at first. So now we can write this function that will only fail when, or it'll only return nothing if all of these are nothing, or any one of them is nothing, I guess. Whoa. Okay, so it allows you to write that. It says, this example shows that a type like maybe has two symmetrical modes of use. Success is represented by just the bind combinator continues the computation only if the previous step was successful. Failure is represented by nothing. The I don't know what to call this. I'll just call it the alternate operator for now. The alternate combinator tries another computation if the previous step failed. We also say that alternate recovers from failure. Yeah, so it can handle nothing. Sure. The monadic structure of optional values give us a nice interface, but is quite uninformative when the computation fails. Nothing does not encode a reason for the failure. We know that. The either data type remedies the problem by adding error information on the failure case. Write the functor and monad instances for either. By convention, a successful return value is encoded by write. We know that. Okay. We're still going to do them because I like to practice. So we already have the either type in scope, but this isn't going to work because we have prelude. So we'll just write a new data type with constructors. And there's no doubt in my mind that I will get one of them wrong, and like that, we'll have to deal with them. Okay, so instance. Again, this is like that repetition, whether or not it's easy, or like even if it's easy, I just want to keep doing it. So if you don't want to watch me re-implement these 100 times, then I'm sorry. Data validation is usually preferable because it can accumulate errors. So doesn't this accumulate errors as well? In the real world, it doesn't accumulate errors here. But it would accumulate errors if you had an either, right? Ah, I see. Okay, so there's different error types in validation. Here, I want to look at that real quick. I don't think I've heard of that before. I might have, but it may have been at a point where it didn't mean anything to me. Yeah, I thought that was how this worked. Hang on. I'm now confused. do 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 do. Wait, is this not? Is alternate? Yeah. I mean, it describes it perfectly, but I thought that that was the behavior of alternate for. Why is either not in here? I thought that was the behavior. But I guess this isn't even defined. Like, alternate's not even defined for either. Defined for option. Unless I'm blind. I don't think I'm blind. Couldn't you just define an alternative for either where left is a monoid? Isn't that all you would need? That's the part I'm misunderstanding. Or maybe I'm misunderstanding what I was doing with this, which is entirely possible. But anyway, okay. Let's move on. That's an orphan. Yeah, true. I've heard that before, but I don't really know why that's the case. Like, if I wanted it, why can't I just have it? Give me the thing I want, Jappy. I want the thing. You can have it. Just makes your type system less consistent. Fair enough. Sorry. Brain will come back to us in a second. Oh. Duh. Oh, you know what I should have done is T. Should have just used said there. Oh well. Lost opportunity. So said. Exactly. um, uh, I forgot a G. Ugh. Damn it. Darn it. Trying to have a Christian Minecraft server. That's the new thing people say, right? When you swear. Christian Minecraft server. I think that's how that works. Okay. Swore. Yeah, I should keep a counter. That's actually a really good idea. I think you can do that with Moobot. I'm not 100% sure. I've never tried it. Right. Turn pure, and then you have monad. Well, right, x, bind, I don't need the parentheses here. Bind F. Every time. What I should be doing here is just writing clearly something like this. Wait, really? Do I have to write L at left underscore or something to make that type check? Yeah, with Hypernerd you can get atomically incrementing counters. I assume you can with this or with Does this not type check? That's weird. It's pretty weird. It's got to be. How do I explain this? Do I have to wrap? It's the same type though. I don't understand why this is necessary. Okay, that's kind of what I was thinking. The phantom type for the right case is wrong. That's right. Okay. So this is actually a different data constructor. Can we see it? Either EB. This will be either EA. Yep. Cool. Thanks, Jampy. Right. That's why you can't do what you can't simplify these. Okay. I'm glad we thought about that because that helps me remember that, you can't do that. You need to get the phantom type correct. I guess it's not really called a phantom type this time, is it? I mean, I guess it is kind of a phantom type, but it's not really. It's much more explicit than a phantom type. Because a true phantom type you never use. This we're using it above the same line. Maybe it's still phantom is the right term, but is there possibly a more correct term, or is phantom the right term? That's basically my question. Oh, I also forgot to do tag type. Maybe. I don't know. I don't know what the answer is. I thought it maybe was interesting. Is it interesting? Who knows? I think phantom is probably good enough. Yeah. Like I don't think anyone's gonna be like, that's not a phantom type. What are you talking about? Phantom type is da 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 da. Except that I know I've done thinking with types, so now I think about phantom types as never being used. Anyway, sorry. Tangent. Right. Functor. Applicative. Monad. Or either. So there we go. Done. What was left? But wasn't going to be used. True. I don't know if that makes it a phantom though. True, like Okay, let's just look it up. What is the definition? Haskell, phantom, type. Give it to me. What's up, Captain Ajani? Is Ajani a Magic the Gathering reference? Couldn't think of the word reference. I've been reading the Learn You a Haskell book. Any other good resources? Nice. I'm a big MTG player. Well, I don't play that much right now, but I was very into it. So some recommendations that we've done from the stream, like you can just go look at recommendations, is actually I forget what the Moobot thing is, but I'll paste this in a second. So there are better references than mine. This is just my personal one, so I'm just gonna show you like all the books that I actually have. Also, we finished this book, so I need to edit that. This book is fantastic. It just goes a little bit further. So if I should mention, okay, when I did Learn You a Haskell, I did not feel confident about my ability to write Haskell at the end of it. So if you feel like good about writing Haskell towards the end of Learn You a Haskell, you should 100% skip this book. But I thought that this book was great, except it's not free. So this book costs like $60. So yeah, so that's a trade-off that I understand some people don't want to pay for. Book of Monads, and I haven't decided. I mean, it's a beautiful resource. We haven't gotten to I would say the meat of it yet. So that's kind of the next resource we have to work on. But I really don't have anything more than that. Like I've personally read this book, Haskell Programming from First Principles, and the Learn You a Haskell book, and I liked all of them. But like Thinking with Types is not I would say a good resource for learning Haskell. So like, what are you trying to learn? Like, what are you trying to look for? Just a generic resource? Hopefully that answers your question somewhat, but I know it's not complete. So I think it's, hang on, just go to, I'll get it. I just don't remember what it is. That's the only problem with, I'm using the stream manager from Twitch now. It's actually pretty nice. It's called Topics is what it is. Yeah. Bang Topics. Yeah, so if you just want to practice and learn, like there's other GitHub resources that are just like more specific. So like there's also these courses. I've been meaning to do this one. This is another one that's a free resource. The FP course is probably a good one for practicing. And it's like a functional programming course. So yeah, I don't have those, Jappy. I should have books though. I can add that one. I'll write it down. I think I have a pen. It's more than books though, right? Like it's potential books that I'd like to buy, courses, and other just generic topics. Like I know for a fact that whenever I read like job descriptions, recursion schemes is something I see quite a lot. And so I kind of want to learn about that. So I don't know, maybe Topics is the right name, but you know, I didn't remember it. And like we're gonna learn these things from the Book of Monads. Okay, the other thing I wanted to look up was Haskell GitHub resources. Like was it this one? I mean, I've clicked on it before. No, that looks too small. This is foundational papers. That's interesting. Tagless final. Yeah, it's apparently just MTL or transformers. Which one? Well, this is not what I'm looking for. There's like this insane might be this one. Awesome Haskell. Yeah, I think it's this one. I'll put that in the chat. So I think I've encountered this before, and it's been like insane to like you can find anything in here. Like, what do you want to learn about Haskell? It's all in here. Um, yeah. Okay. Uh, Recursion schemes isn't all that fancy. I really like this infographic. Ooh, infographic. Yes, please. Let's bring that down here, and we'll star it for like. Go in here. Thank you. Whoa, neat. Okay. We're gonna read this later. I'm not gonna read it now. Persian. Okay. Then Ajani says, "How did you get started with making an actual?" Well, Ajani, I've never made an actual program in Haskell, so we're going to though. And I would say that I don't know. I legitimately don't know. I'm gonna have to learn on the fly because if you read my little bio at the bottom, like underneath the profile, you'll see like I'm not even a yeah. You can, Jappy. Um, um, I have no formal training in programming, so like I don't even know how to format a simple project. Like I really don't. So I don't have a Jappy and Lumi are probably better resources for that. So I also claim underneath, by the way, to not listen to me. Whoa, New Maid's here. Also subscribe for 4 months. Hi, New Maid. We miss you. I know that you're busy with stuff, so we missed you. You've been gone. But yeah, so I need to finish reading what you said. I find myself following along with all the examples in the Learning a Haskell book, but I have a big scratch pad of various functions right now. It's very cool, but when does it click on how to use that to make an actual program? Yeah, I don't know the answer to that. I really don't know yet. Let's look at Jappy's post here. Thank you so much for the subscription, Numade. I really appreciate that. I'm working on another donation setup. Not that it applies to you because you guys are subscribers, which is very helpful. But I want to be able to accept one-time donations instead of the recurring ones as well to pay for like the stuff that I have. So like I bought 2 monitors, I bought this chair, and I'm hoping that maybe someday we can offset the cost of these things and buy more stuff for this stream, like emotes and those sorts of things. Okay, so this is a pragmatic Haskell simple servant web server. What else do you have on here, Jappy? Jesus, that's an aggressive photo. But yeah, this seems like a pretty useful resource. It's just like starting from scratch and how do you do this to get started? And if you've not heard of Servant, it's just a web server essentially. We actually have a YouTube video for Servant of us just going through the. I'll plug YouTube because we're here. Where I go through and I basically do the tutorial for Servant, and I'm actually using Servant at work now. But I can't show that code on stream yet because it's not generic enough. I've totally lost my train of thought. What were we doing? I think we just finished this thing and we were just trying to help Ajani, which is still an awesome name if I didn't say that already. I think I've said it twice, but I'm going to say it a few times. Programmers should probably play Magic the Gathering. It's just a big problem solving thing. It's very fun. Okay, I'm done. All right. It says yeah, actually here's a question. Why is either called except in Transformers? Why does it change names? Why don't they just call it either? Or is it just that either is a poor name to begin with and it should be called except? Really don't know. We're learning things. I post mostly about things I encountered during building things. That post was from when I started using Haskell professionally. Oh, nice. When was it published? I didn't even notice the time. Did I not save it? Gosh, I'm stupid. I would like to read it more carefully later, but I don't want to read it on stream. Oh, it's just last year. So you okay, so you've only been doing blog posts. What's up, Oren? Man, everybody awesome is here. Love it. Very happy to see everyone. Okay, so the commonalities between these two monads, which two monads? Either and except? Either and... I'm not sure which one. Anyway. Oh, I see. They're comparing the types in Scala and in Haskell, but we're sort of ignoring the Scala code. I guess so. I've almost been doing Haskell as long as you. How are you so much better than me? I wish I was smarter. That would be helpful. Oh, I guess I've been doing this for 10 months. So I'm dumb. Anyway, I'm saying that mostly jokingly. Like I'm trying. I don't really think that I'm stupid. Like I am picking things up, but I feel like I'm doing it really slowly. Well, that's true too. Yeah, that's a good point. I only do 6 hours a week versus 8 hours a day. That's a pretty different experience. That's a fair point. But I am mostly joking. I don't really think that I'm stupid. It just takes time to learn this stuff. So okay, so apparently Monad Plus is a subclass of Monad. Okay. So it's like applicative is to alternative as Monad is to Monad Plus. Is that the idea? I guess we'll find out here in a second. Yeah, exactly. Just go to school for 6 years and you can get a PhD. Please, I hope that's not true. Just makes mine worthless. I'm gonna write these, but I think we're gonna have to comment them out. But that's fine. Oh, so Oren, that's a new thing that Twitch is doing. So the first 15 subs on the channel get something called founders. So that's what that first is. So Newmaid and Lumi are within the first subscribers of the channel. So they get that little first next to their name. Yeah, it's like a new thing that Twitch is doing. So, if you want to be a founder. Yeah, it's like a really nice thing. So, I think actually, I don't know. Lumi, do you stream? Have I never, do I just not catch you on stream? Because I feel like if you don't, I would like to watch you. Okay, that's fine. Never subbed. Wait, what? Took a note, never subbed to anybody yet. What does it mean? What? Did I miss something? I think I missed something in chat. I'm not sure what you mean, Oren. Oh, that's fair. I mean, I'd still watch you go through your like closure or whatever, closure script, anything. Okay, I think I'd like to see the way you think. Okay, I think it would be interesting. Newmate as well, but I think he likes to also just watch. Oh. So, okay, well, let me explain what subscriptions are because it's essentially the easiest way, or maybe the least involved way to support streamers. So if you feel the need, I'm not telling you have to. You basically in the top right, there's this subscribe button, And essentially what you're pledging is that you're going to give the streamer basically $5 a month, and that is how you support the stream. So if you feel like it's worth supporting, you can subscribe, and it costs you, again, $5 a month to add support to a channel. And that's how streamers, like the big time streamers, that's the only way they make money. And some people do that as for a living. So I don't do it for a living, so I don't really care if you sub. It's definitely appreciated, but it's just paying for like additions to the stream. I'm never going to be able to make a job out of this. Okay. So empty, and then okay, so maybe I was incorrect about the way I was talking about alternate earlier, and I probably was, but yeah, like I try to support small streamers that are doing things that I'm interested in. That's basically it. So like I sub to Jappy, for example, because I want to support Jappy, which is also why I was asking if Lumi and NewMade stream, but I'm pretty sure they don't. So I tried to sub to them. But again, I'm not saying you have to. I'm just saying. Don't feel obligated to do that. So I had to comment this out because I've already defined this operator in here. So that's why I've commented it out. I'm just putting it here so that we can talk about it if we need to. And another thing is that you can gift subs to people. So NewMade is also extremely kind and was able to do that. Actually, I should have done that instead, but it is what it is. You beat me to it. So yeah, if you are subscribing, actually you don't even have to subscribe. You can also just gift them to people. So now if you type in chat, you'll see that you are a founder, and or it should happen pretty much immediately. So, you know, there you go. You are officially a founder for our channel. So thanks to NewMate, thanks to Oren for hanging out. All right, so it says any monad plus instance must also be an instance of alternative. Yeah, that makes sense, because if this is required to be applicative, oh wait. Any monad plus instance must also be an instance of alternative, although this requirement is not encoded in the definitions. I see. Because applicative, or well, monad plus is a stronger guarantee than alternative. Not stronger, that's not the right term. It's a more strict version of alternative with a funny name. Yeah, see, there's your little first. So right. So write the alternative instance for either E, int, you need a default element to build a left value. Requiring the error type to be a monoid is the common solution to this problem. Sure. First time gifted, nice. So yeah, welcome to the wild world of Twitch and how people make money doing it. I don't know what the cutoff is for viewers, but I think pretty much it's around like 100 people for it to be like even close to making any real profit. But that's not why we're doing it. So please don't feel obligated to do something. So, oops. Exercise 7.2. I don't like talking about this stuff if it's not obvious. Well, so like with viewers, you can run ads, right? And the more viewers you have, the more money you can make from the ads. not that many streamers are showing ads during the uh while they're streaming, only when they're walking away. Yeah. Um mhm. It's not a lot. I don't think I'm allowed to say how much it is, but it's not a lot. I'm trying to decide if I should even waste my time running them because there's not enough people. Like when I walk away, for example. Like I need to go get water. So I'm gonna do it after this. But if I should even run one, like if it's even worth. Yeah, exactly. So the way I don't know if you've ever heard of King Gathalion. He's a pretty famous streamer at this point. But like he would only show an ad if he was walking away from his computer. Like he would never interrupt like what we were doing with an ad. He would always like have to, use the bathroom or something, and then he would show one. And that was the only time that. Is he the scam baiter? I don't think he's a scam baiter. What do you mean? Oops. I know what you're talking about. No, that's Kit Boga. Kit Boga is one of the funniest people that I've ever experienced. I love listening. I'm subbed to that channel actually. If you get a chance to check out Kit Boga, please do it. You will not. It's hilarious. Um, yeah, you should probably watch him. Yeah, I've been getting into that. But yeah, he's got that like I think it was like 15K today. So with 15K, you can make a career out of it, and he is. So that's what he does for a living. Sorry, I'm losing my train of thought. So we need to force. Uh. Well, no. We're gonna say monoid E alternative. I'm still not used to the change that I made, but uh, do I need to get applicative? Yes. Excuse me, wrong way. So we need to give empty. Wait, uh, this is supposed to combine the x's if we get two rights. Is that correct? Should these both be monoids or no? This should be implemented like this, right? Pretty sure. Oh my goodness. Except Oh, I guess I didn't even need to use the either prime here because this isn't even implemented. So the question is, oh, I guess you can't even have a monoid of the A type here, right? Because you don't reference it. So you could only ever, like, if you wanted to, you could say, right, this doesn't matter. You could do this. Oh my gosh, I can't type. And then or mopend doesn't. I mean, it doesn't matter. But I guess if you're going to include the monoid of E, you might as well combine them, right? I don't see any reason not to do that. So question, is it weird me looking up this high? Like, does it look like I'm looking up to the stars when I'm looking up? I can't tell. I know when I was looking over here, it was pretty far, I guess. I don't know if it's weird or not. I'm going to move it down a little bit, but I can't move it down that far. Otherwise, it's just be in the way. It's looking like I'm thinking. Okay, that's good, because I am thinking most of the time. But I'm just looking at chat. So. I actually really like the new Twitch stream manager interface. It's kind of nice. Okay. Anyway, sorry. I'm getting very... I need to go get water. That's what I need to do. So, true. Okay, let's see what we got here. So, as is always the case with monads, much of the power of using abstractions such as alternative and monad plus come from the ability of generic functions that work on any of their instances. In Haskell, these utilities can be found in either the control monad or control applicative modules. Don't care about Scala. Continue. When dealing with error pattern, hang on, I need to put my slippers back on. When dealing with error conditions, the following pattern is common: if some condition, then else empty. This code could be part of that validate age function, which we sort of talked about for a while. Solve what problem? I was under the impression that those are solving different problems as well, that those are orthogonal. But I don't really know that much. Okay, so all right, let's look at this. So we could write the following function that won't compile because it won't. I really wish we didn't use this function every time, but I understand why. Let me this up. It's sort of a different content. Read. Right. We could do this, but there's another way to do it. Okay, and then we'll yeah, this function is some function that generates a, or that inputs a t something. Oh, you definitely need to follow Jappy Jappy. He streams like during the day, like day as in Eastern time for me, and he's doing pretty interesting stuff with Servant and FRP. The what is it called? Reflex. Yeah, you definitely need to give Jappy a follow. Uh, fantastic, fantastic streamer. He's fun to watch too. He's also doing everything in Nix and like pretty interestingly. He's like he's got a pretty fun setup. Okay, so anyway, we can change this if then else to a guard. That's the point, I guess. And we get guard. Guard is an utility function for anything with alternative, and it just returns a monad, or yeah, an M of unit, yes. So essentially a no-op. In the next section, we're going to discuss the implications. I forgot my water. Head. I won't interrupt you guys. All right, so the first function, I should have kept reading, sorry. Implications of making lists an alternative, but for now, we can introduce two generalizations or common list operations that only require the structure provided by either alternative or monad plus. The first function is msum or asum, depending on whether you require an additional monad constraint. So applicative sum versus monad sum. Type is a bit scary, but the definition not so much. I don't think that's very scary. I'll just write them in here. Asum reversible t alternative m tma to ma. Folder. Yeah, so I'm gonna comment this out because this is causing annoying issues. Find myself in RX. What's RX? Oh, empty is just mempty, right? Just for alternative. I was like, what's empty? All right, and then msum is the exact same thing, except this becomes monad plus. Let's just write it. Traversable t. What did I just say? Monad plus m. No, I don't need to write that. M. Not memty. What is it? M0. Yeah, I don't know what you guys are talking about right now. I'll just let you guys talk. I've not done any concurrency in Haskell yet. Another book on the list of things to do. And if we don't get permission to work on the purely functional data structures book, we might ask to do the parallel and concurrent programming book next. I do HPC on a daily basis, so I should probably know how to do concurrency in this language. Okay. Yeah, so in other words, given a structure that contains elements wrapped in an alternative, asym joins all of them via the alternative operation. When T is a list, this definition is equivalent to the following formation. Yeah, we know what this looks like, generally speaking. Yeah, I mean, Nix has been on my list of things to learn as well, but I feel like I want to go deeper in Haskell first. Like, I don't need Nix to do what I'm doing yet, but I probably should learn Nix at some point. Maybe that was your. I think that's what the Nix question mark means. Okay, and then apparently, yes. Why would it not? Oh, okay. Yeah. I think foldr is fine because you have something traversable, I guess. Or maybe that you're thinking of something different. Well, that's okay. Tired happens. I've been tired on this channel before and not been able to do like anything. You can just say tired. I look like an idiot when. Okay, so filter. We're gonna write a filter function apparently. I mean, I'm not really writing it. It's just in front of me. Mm-hmm. Okay, so monad plus m a to bool m a m a. That looks like something we're familiar with. Let me put this up top. Oops. You can use ACO with F sharp. I've heard that term before. I mean, I know what ACA is generally. Okay, so we get do syntax. Say get X. I feel like this looks terrible doing it this way, but do I px prime? What? Kitty needs some love, so we're all gonna meet Andre 3000. Here, bud. So this is Andre 3000, my youngest cat. Almost a year actually. Old. 3 stacks. He's kind of needy for a cat, which is surprising. Although he wants to get down right now. Usually he wants to needy. Sorry, you can't see him. Okay. Hey, no. You can't get back there. He's a closure guy. Okay. So can we write this like A? You're literally trying to do this? No. Hang on, I gotta deal with this cat. Too fat. Used to be little, but you're too fat now. Oh boy, I'm gonna have to deal with this. I need to go get. Hang on, sorry. Kitty problems. Here, go up here. I just gotta scare him with the spray bottle. We use that to get him off the table. But if you just set it there, he's too afraid of it. So can we just write guard? Where does this function come from? Okay. Is it control monad? Yep. I should have guessed. Right. And then we need to probably comment this out. Those are just instances, so those should be fine. There you go. We just need to comment out that monad plus. Where you going, dude? Crazy. Yeah, he's going a little nuts right now. Excuse me. So this is the same thing, right? I suppose we can test it. Two birds in one shot, because I'll get FRP ACA streams with option to go deeper into actor model structure if needed. That's a pretty important thing. So, okay. So M filter. So we need a predicate like greater than 10. And we need a monad of A. So this will no language wars, folks. We don't language wars. I didn't notice this. Oh, it was 4 minutes ago, so it wasn't that long ago. Johnny, Thank you so much for the follow. Yeah. This channel is not about language wars. um well, let's do 5, 10, 15. My guess is this only returns 10. Oh, they were greater then. I was expecting it to only... Oh, I guess this is... Did this only return 10? Probably not, because of the way the bind operator works. Oh, well, that's actually really funny too. I didn't think about it like that, new mate. I think you're intentionally being a troll, but trying to be funny about it. At least you're lolling about it now. So, internet's an interesting place for sure. Scale and closely. I really want to look at a Lispy language at some point. We'll get there. Okay, so the reason this is this way is because of the way the bind operator for list works. So we could also do this on, I guess, just 11. Okay. Can't think of any other structures to try this on, but this kind of makes sense to me. I do like this. This is pretty easy to read. I've never used guard before. You could write this, I guess, as... Oh man, did you do this? Is that correct? If that's correct, I'm gonna... I shouldn't have done that. Oh well. I think it is. Nice. Get elevated. And then obviously... Wait. Oh, I need X twice. I don't know how to do that. How do I get X twice? I don't remember how to do that. But I see why this is failing. Because this is actually just a... I mean, that's a point-free function. There, well, that's just a function. But it also takes X. Oh yeah, I gotta go get the squirrel. That's a good point. Page. I am on page sorry, 91. Yeah. There's gotta be a way to piff solve this. Let's do it. And then we'll get the squirrel. what is it called? Pointfree.io. Yeah. Bam. Weird. I wouldn't have come up with that. Oh, whoa. It's getting rid of P as well. Insane. It went all the way. My goodness. I just wanted to get rid of X. Weird. Okay. I wouldn't use this. This is too hard. But I did want to see if I could write this. So I think what I'm going to do is actually comment this out and write this code. And then we'll put this down here. How do I read that? I'm gonna just use skin because I'm not sure what the front is. Sorry. It might be something. I just don't know what it is. So I'm gonna call you skin. Things are well. We're just programming in Haskell. Oh. Bot. Hey bot. Nice. So say hello to the bot, everyone. They'll never be back. That's actually the second time that's happened. Kind of surprised by that. I think it was essentially the exact same. Science, technology forever. This is awesome. Man, I want bots that come around more often. It's a really nice bot. I suppose I could ban them, but like they'll probably never write again. And like I need the viewers, so that bot can watch me. Unless it continues botting, then I'll get rid of it. Okay. Haskell, the errors library provides versions of many common functions that replace exceptions or generalize a maybe type into a generic monad plus instance. Some examples are the indexing operators for lists and the always demonized head function. We'll just look at that. You guys didn't say hi to the bot? How rude. There it is. All right. Maybe m0 return dot s dot head may. I don't this function. Assume it's up here somewhere. Anyway, this errors package is like taking errors to the maximum. Apparently. If you have behaviors in your code that might fail, consider abstracting this failure into a generic monad plus. Without any doubt, adopt the errors library into your projects. Is anyone using this errors library in their actual projects? I guess that question essentially goes to Jappy if he's still around. He's the only one writing Haskell professionally as far as I know. I think Johnny is learning as well as us. new mate is learning as well. So mostly a group of people learning, a collective learner group, classroom. My God, I have a billion messages on my phone. Fun. All right, so now we're going to section 7.2. Logic. Here, I'll go up like this and start from here. As hinted above, we can make lists an instance of alternative and monad plus, since list operations embody a type constructor with a monoidal shape. It is conceivable that when that monoidal structure is already known, it can be reused in their definitions. Okay. Is a rough... Oh, I see. Okay, because we're using the list, we don't really need to implement anything because we already know them. Because we have the monoid. I guess is what that's trying to say. As a rough approximation, the absent value nothing corresponds to an empty list, and a wrapped value just x corresponds to a singleton list of x. But we do not stop there, as the list monad also embodies the idea of a computation that returns several values. By using this additional power, we can recreate logic programming in our favorite language. Okay, I've never done logic programming, so that could be interesting. The core idea of logic programming is to express your program as a set of basis facts plus a set of rules that allow us to derive more knowledge from those facts. When faced with a problem or programmatic question, logic program starts a guided search through those facts and rules to find whether the given question holds or not. In other words, whether some logical formula can be derived from the given set of rules and facts. At certain points, the search procedure may signal a partial failure. In those cases, the program backtracks in order to search another part of the solution space. Okay, interesting. So it says, consider the following example, which can be found in any textbook about Prolog. I've never been a big fan of just simple type aliases like this, but it's fine. Those are the people I see right now. I know there are other people. I'm just gonna use this so I don't have to recreate. Sorry. I've never seen that name before. Oh, and then I'm not gonna create any extra people. We're just gonna do it the way they have it. People, relation, yes, person, I don't feel like typing all of this. I wonder if that's their child or something. I just assumed that Elena was Alejandro's wife because he used that name first. So maybe John and Mary have a kid named Tom, and that's Alejandro and Elena have a kid named, I'm not sure how to pronounce that. Okay. So, sure. I don't know. Taking these facts into account, we can express the grandparent-grandchild relationship as a monadic computation over the facts. Oh, it's parent-child relationship. Okay. Yep, prologuing, apparently. Delicious water. Thank you, Mubot. I need some more water soon. It's not a big cup. So this is and then and parent child. Person. Okay, so wait, why is this complaining? Oh, because I did that again. I can't spell the word guard. Too hard. Apparently too hard. Okay, it's 10 o'clock, so I don't need to go get more water. We're gonna finish in a little while. Okay, so basically iterate over every combination of these where the parent is the same, or I'm sorry, where the parent, yeah, you're trying to find relationships where although there aren't any. Oh, there's one, right? Where John and Tim are, John is a grandparent of Tim. That's the only one though. I was like, I can't find another one, right? Yeah, that's the only one. Okay. How does this work? Well, I sort of just said it, I suppose. Remember, the list monad generates all possible combinations of grand P, parent, parent prime, and grand C from the set of parent-child relationships. Then we only retain those combinations where parent and parent prime are the same. The result is a set of tuples related by an intermediate person. This expression, if this expression reminds you of a join in SQL, you're absolutely right. Another important logic language is Datalog, used to query databases. I've not done that. I've not done a lot of join, but I know the concept through pandas. Okay, so define exercise 7.3. Oops. Define sibling. Oops. Sibling relationships to return one tuple for every two people who are siblings. In other words, they share the same parent. Easy peasy. If I could spell, it would be easy peasy. Do. So, parent. Child. Something like this. All right, so who does this include? Mary and Tom are the only two siblings. Then I guess you could write one the same way for children that's like, you know, father or sort of parents of, although then you would want to like have this, I don't know how to pronounce that. Quipu? There's no way that's how you pronounce that. We could ask my girlfriend. She might know. I'm gonna go ask her real quick. Actually, I'm not, because we're almost done streaming. I have no idea. I think they're Brazilian. There was someone here from Brazil earlier, if I remember correctly. Mateus is here. Okay. I think that's right anyway. I should probably run these. Dang it. So, sibling. Weepoo? Just seems so wrong. That's clearly not correct. They are not siblings. So you need to filter out any cases where they're the same. Because the only siblings would be Mary and Tom. Although this is going to produce all combinations, right? So it's going to produce these. So like you really, I guess what you really want it to have is a set or something at the end of it. Because I'm guessing that This one is much more straightforward because there's only one linking case, and because it's linking forwards only, you don't have this problem. Maybe I can fix this. I was just not thinking about it correctly. Nope. This is... But I don't see how you get rid of the flip cases. Parent. Parent not equal child? How would that work? Because we're getting, so we get this return one tuple for every two people who are siblings. Yeah, I think it's close, but I think you still get the combinations. Yeah, right. The only way you could remove those combinations is by like searching through the entire list when you're done. I don't see how you avoid those combinations in this case. I guess you could oh, you can't do that. Like I'm thinking of, in like some, in an imperative language, for example, what I would do is something like draw the first combination and compare it with everything at the end, and then get the second one and everything at the end and compare it like that. But I don't know how you do that in here. You could, I don't know. I guess you can zip with repeat of parent child and then go grab those. But anyway, I think we're thinking way harder than we need to for this. Maybe they'll say something, but I think this is probably fine. I mean, you could say like, this is actually the correct answer, because you could say that actually I think that's the way you do it, is this is the correct answer because you're saying Mary has a sibling Tom and Tom has a sibling Mary. You're not implying that Tom has sibling Mary by writing this. I mean, our data structure does not represent that because it's just a tuple, but I think that's the idea. Or I don't know. I'm justifying why I think it's deficient, I guess. So, anyway, it's probably fine this way. Oh, that does say return one tuple, so that I might be missing something here. I don't know. It's fine. The bind construct of the list monad works like a conjunction. A value has to satisfy all of the conditions in the do to make an appearance in the list. Here are two additional definitions that find all the triples of numbers from a list such that two of them added together equal third, or such that the sum of the squares of the first two equal the square of the third one, i.e. the Pythagorean triples. That's fun. Let's write a little. I'm not going to write this. It just says like you can model any logic programming problem by using the list monad and taking advantage of its monoidal structure. Um, Feeling brave after our new accomplishments, we decide to obtain not just the triples from a finite list, but any triple among the natural numbers. In other words, we want to get the list triples. Okay, we say that the list monad is unfair because it keeps searching on a branch until it runs out of candidates. In this example, the execution proceeds by choosing one. I should explain what I'm doing. Sorry. Yeah, I do know that actually. I do know that. We actually, Lumi and I were talking about this recently. We were having a conversation about, or yeah, we were trying to understand exactly how list comprehensions are desugared. That was the idea. I think that's what we were talking about anyway. So I need to write the following. I really don't want to. Wait, you can do this? That's insane. I did not know you could do this. What? Learn something new every day. Learn something new every day. Kitty, you're insane. We get it. No. Oh my god. I'm not sure I would ever, for a matter, should move them to separate lines though. Well, we'll see. Let's try it. Is it this in Haskell? Nope. What is this? H-linting. What? Didn't do anything. What is it suggesting? Yeah, I think that this is not a it yeah. I don't think it likes this. Let's see what our formatter does. Doesn't seem to do anything with this. This is very strange though. I don't know that would anyone use this in production code. I feel like this is really ugly. It's interesting, like the fact that you can do it, but I don't particularly like it. And I presume there has to be a space here. Or there can't be a space here. Oh no, it's fine. Oh, that could be. That could be. I don't like this. It's bothering me. It's still saying this. Yeah. No, that makes sense. Like if you're defining like constants or something. Is there another way to write this? Like it's not suggesting anything. It doesn't do anything. I don't know what it's asking for. I mean, ideally, I guess you write a list comp. See if there's anything. Reduced duplication can mean so many things, though. No. Yeah, I don't think we're gonna be able to Google this easily. I don't know what this is complaining about, but fine. I mean, ideally, I guess you would just use a list comp for this, but there might be like a. But the replicate puts things in a list, right? Can you create a tuple with 3 things in it, for example? So take an int and an n and make an n and n. You can create list n, that's a thing. That's replicate. But is there a replicate that takes a generic? What if we do mn? No. I'm not sure how to, if there's a convenient way to reduce this replication. What I was thinking about is like, if you tuple up ns or something. No. This is going to be such a pain with this being open now. He's going to be really problematic. Anyway. You could do this on one line, like, but that's not beautiful. You know, like this isn't beautiful. Maybe this will give a different hlint error. Oh, yeah, this doesn't even work. You would have to do something like this. And then these are, yeah, this doesn't work. So I have no idea. If anyone knows what this is asking for, please let me know. I mean, I know it wants me to combine these things. How? Well, oh, it's saying combine with the other thing, right? Wants me to combine with this. Yeah, it's like the combination of these two things looks like it's duplicated, but it's really not duplicated. You could do this with replicate, but I don't. Maybe you can do. I want to see if it works now. You could do this, right? Because replicate operates in the list monad, so it can extract this. But does this complain? Well, no longer complains about the repetition, but I don't like this solution doesn't look very nice. I mean, it's not terrible, I guess. Whatever. Okay, stop. Stop thinking about this. It's a waste of your time. Okay, so now what it's saying is that if you want to write like something like this, you can't because apparently the list monad is unfair. So you can you it keeps searching on a branch until it runs out of candidates. In this example, the execution proceeds by choosing 1 as the value for x in sums, then choosing 1 for y and also for z. That combination does not satisfy the condition 1 plus 1 equals 1, so it is discarded. Now we backtrack in the innermost computation, leading to the value of 2 for z. This combination is a triple and thus reported. Then we keep trying with larger numbers for z, but we never can choose one. Oh, I see. Okay. I see what it's trying to point out. Like, we never hit the alternative case, so it just loops forever. Although it would loop forever whether no matter how we did this, wouldn't it? The solution is to use a more refined monad for search that includes fair combinators in addition to unfair ones. The package logic T is probably what provides. Yeah, logic T is a transformer, I assume. Provides a logic monad with those abilities. In order to understand how to use logic, it is better to desugar the do notation with explicit binds. Okay, let me write that. Oops, that's not what I wanted to do. Should have done that the first time. No reason to go all the way to the bottom first. Okay. So rewrite. How does this get formatted? Nope. It's easier to read for me anyway. Ideally, this would also be on the other line, I suppose. Just makes the structure a little easier to see. Although I suppose you could also just do this, and it would be fine as well. Okay. Says to perform the conversion, we first lift each integer value into logic integer using return. Then we combine the whole list using the asum operation defined above. Okay, so we need to go get logic. I have no idea how large it is, so. Oh, well, it's tiny. Probably in control, monad, logic. I don't know which one. So, suggesting we make we'll just do this, it's fine. Okay, so we return the list, and then what is asum again? I already forgot. Oh, we just fold it with alternative, right? Okay. That's the only change you have to make. And then you can do something very similar for oh, I guess the first one's the only one that has to be fair, huh? Oh, no, the other one has to be as well. Oh, okay. So it says, sorry. This actually isn't the correct answer, but it just gives you the idea of how to use logic. So to produce all of the fair triples, you need to do apparently the following. Where did that come from? Wait, what? We need to make the enumeration of possibilities fair. To do so, we extract that part into its own function and replace the unfair bind operation with its with its fair version. I see. I see. It kind of looks like this. Except we lose this guard and we replace those. Okay, and then we can write this is not quite right, but type checks. Doesn't this need to take NS? Yeah, I feel like that's a typo. Fair triples itself, well, maybe it isn't a typo. I think it is, though. Yeah, that was just a little typo. Um, so do I need to write the same thing for... So... gonna be basically the same thing. What I don't understand is what I'm getting from this yet. It's not clear to me. So if I run triples prime, what's gonna happen? What do we think? It's just gonna... Well, here's what we can do. Look at how hungry OBS is. It's thirsty. Uses so much CPU. Google Chrome and OBS. Welcome to the world of streaming. All right, I just opened that up to make sure I don't blow up my computer. I probably need like a run. Well, I clearly don't want to observe all, right? Like that's probably the point. I want to get, I don't know, 2, I guess. Not really sure what's going on here. Oh, yeah. Yeah, okay. So on the next page, it says observe. So if we just observe, oh, we import, well, control monad logic, observe triples so if we observe all, what does it do? I mean, does it start printing out as it finds things? Just watch our RAM there. That's kind of cool. It doesn't blow up in RAM either. That's kind of neat. I've never done this before. And it seems to operate in constant RAM space as well. Although maybe it's just going so slow that we never see it, but that's kind of neat. And there's also apparently observe many, like we get the first 10. That was probably already pre-computed, or those ones are just really fast. Neat. Okay, so it says the same unfairness problem also appears with disjunction. Since sums produce an infinite stream of triples, we never see any Pythagorean triple coming from triples. The solution is, again, changing to a fair disjunction operation. Relieve. That's probably another. Haskell REPL is really slow compared to optimize. Oh, that could be. But it's like if I want to do that, I have to put it in my main function and then run it. But I was trying to avoid that. So apparently there's a function in here called interleave. I see interleaving. Of course. That's the Oleg, right? There it is. So apparently we can stick this interleave function in between the original ones and it will still work, by the way. And I'm not concerned about RAM, so. So instead of using this, you can use interleave. should type check. And then supposedly it's okay. Oh, but it's still not a logic. Okay, anyway, that's fine. The yeah, never mind. Oh, let me delete that because that, although it type, wait, it shouldn't type check, should it? Oh no, it'll type check because it's basically the same type as what we were using before. Okay. It says, in this section, we have only scratched the surface of the power of logic programming. In general, in the list and logic monads in particular describe and solve search problems. The interested reader is referred to the paper behind this entire article apparently is mentioned. So this article here. Apparently one called The Reasoned Schemer. Okay. Anyway, I think we're done for today. It's 10:30. I usually stop at, well, it's 10:40 technically. I usually stop at 10:30. So we're gonna push this code into a new pull request. Do you think that's worth getting? I guess I'm not particularly interested in logic programming, but maybe it's worth getting. So we are going to quickly commit this code. I did it backwards. And create the pull request. So we're on chapter 7, section 7.2, header. Yeah, thanks for showing up, new mate. It's been a while since we got to see you, so I'm happy about that. Also, like, we have 6 viewers right now, which is like pretty awesome. Whoop. Still knows GitHub. So book. All right, there's our PR that we're gonna work on. I guess this is kind of a nice way to just show people that we're still working. If you see pull requests, I don't know. But you can get this one from there if you're interested in getting the book. It's on Amazon essentially. There's, as far as I can tell, there's really nowhere else to buy the book. And there's the code for the book as well, so it's available and you can check it out if you're interested. But that's it for me today. If anyone has any questions, feel free to ask.